Welcome, everyone, to Clean, Green, and Blue Ocean Energy and Marine Decarbonization in Greater Victoria. This session is part of the Rising Economy Conference, an immersive virtual and in-person event hosted by the South Island Prosperity Partnership. My name is Sydney Coles. I'm a journalist with Capital Daily here in Victoria and have doctorates in comparative literature and applied psychology. So as someone deeply invested in interdisciplinarity, it's exciting to see the Rising Economy Conference's list of speakers from across so many sectors, including bioinnovation, film, and aviation. My team at Capital Daily is pleased to be one of the media sponsors of this event, and I know everyone is looking forward to the presentations and conversations that'll take place today. First of all, I'm going to describe a bit of the format for today. In a moment, I'll turn you over to the speakers, but first of all, a quick overview. About halfway through the conversation, we'll be taking your questions for our speakers. You can submit a question anytime through the Zoom Q&A below the video. The session is being recorded, and you can submit your question anonymously if you'd prefer. To interact with attendees, you can use the Zoom or WOVA chat. The production team will monitor the WOVA chat and Q&A for those joining us through the app. Finally, if you're posting your takeaways to social media, please use the hashtag Rising Economy Week 2025. Our moderator today is Jason Goldsworthy, Executive Director for COAST, Centre for Ocean Applied Sustainable Technologies. With over 20 years of international experience in managing engineering, business, and projects, Jason brings leadership, technical, and commercial aptitude to the team. His experience spans multiple industries, including renewable energy, urban development, environmental consulting, mining, and commercial and infrastructure construction. He's worked with large multinational corporations, as well as being involved in several startups. He has acted on several corporate boards in both Canada and Australia. Jason holds a PhD in engineering from the University of Adelaide, Australia, and is a member of the Professional Engineers and Geoscientists in British Columbia. Over to you, Jason.
Thank you, Sydney, for that very warm welcome, and thank you so much to Capital Daily for their support through Rising Economy and more specifically for our session today. I guess I don't need to introduce myself, but I just wanted to, before we get into the discussions, a couple of matters. First of all, I just want to recognise that today I'm sitting at the Ocean Innovation Hub, which is Coast's co-working facility here in beautiful Victoria, which is on the traditional territories of the Lekwungen-speaking people, today known as the Songhees and the Esquimalt Nation. But Coast's mandate is actually to support BC companies and evolving and growing and entrepreneurs in the blue economy. Coast is a South Island Prosperity Partnership initiative that was launched 3 years ago now and has grown over the last 3 years in taking advantage of the blue economy opportunity, which is tipped to be worth around $3 trillion by 2030, or given the current exchange rate, probably about 4.5 trillion Canadian dollars, which sounds much more impressive. Coast is here to support those innovators, new technologies, and really pushing the boundaries of utilizing and working with the oceans in a more sustainable manner. That means, the blue economy spans a lot of different sectors, anything from sustainable aquaculture to ecotourism, and even things like conservation, restoration, and protection. In 2024, Coast went through a survey of what are the companies in BC that are really what sectors they're really involved in. And there was a real theme that came out of that, which looked at energy. So ocean energy, which is the production of energy from ocean or marine sources, and then also marine transportation. And with organizations like Seaspan and BC Ferries, and the Victoria Vancouver Port Authority being the fourth largest port in North America, there's a huge push on what the marine transportation and marine sector can do with in the blue economy. So today's session is really about not just energy production, but it's also about marine decarbonization, which is actually about energy. A lot of shipping is required, a lot of energy is required for shipping, a lot of energy is required also for ferries and other sort of marine aspects. And decarbonization is about transitioning those sectors over to a cleaner environment or a cleaner operation. So today we have panelists on the session today talking about a multitude of different things. There will be definitely the concept of marine decarbonization and what are the pathways that are looking at in the sector, but then also the needs and how do we meet those needs or those demands with respect to energy generation. The discussion, I'm hoping, will talk about some of the visions that we're seeing in the sector, some of the barriers that we're really being faced at the moment, and what are the opportunities not only for the marine decarbonisation and ocean energy sector, but what are they for Greater Victoria, and why is Greater Victoria in this region very well poised to be a global leader in this sector? So we have 4 fantastic speakers today. I'm going to introduce them individually. I'm not going to go through their full bios. They've got some presentations to share about the work they're doing and their own pathway in this session. But I'll come back and introduce each of them. They'll give a 5 to 10 minute discussion, and then we'll start the panel discussion after that. First up, I'd like to introduce Saeed Dolatabadi, who's a PhD student in mechanical engineering at the University of Victoria. He's focusing on green shipping corridors, and it's a very apt discussion to kick us off. So over to you, Saeed, and look forward to your presentation.
Yeah, thank you. So let me share my screen. So you have my screen, yeah. Okay, good morning, everyone. Thank you, Jason, for having me in this panel. I'm Saeed, doing my PhD in mechanical engineering at University of Victoria, focusing on green shipping corridors. Today, I want to talk about the role of marine transportation in business economy and how its energy transition can provide opportunities for investors in this region. However, we know there are many challenges. I will also discuss the concept of green shipping corridors and its role in decarbonizing marine transportation, particularly in the Pacific Northwest. And to start, I would like to give you an insight into the role of global marine transport in our lives and its environmental impacts. As you can see here, currently around 85% of global goods and around 35% of energy products, such as oil and gas, are transported by ocean-going vessels. And yet, shipping alone contributes to around 3% of global GHG emissions. That's why international and national strategies such as those from IMO, International Maritime Organization, and Canada's GHG policies are driving the push for low emission shipping solution. So in this regard, IMO introduced a GHG reduction strategy that you can see here on the left, actually reducing CO2 emission by 40% by 2030 compared to 2008, and being zero emission by 2050. Actually, the green line, and the blue line shows the uptake of zero emission technology or fuels, and the red line shows the IMO GHG emission reduction targets. And on the right, you can see the Canada's GHG strategy. We call it NDC, submitted to IPCC, and which is somewhat aligned with the IMO GHG strategy. Okay, let's explore what are the solutions and how a green shipping corridor plays a key role in this transition. First of all, what does it mean green shipping corridor? A green shipping corridor is a designated maritime route where clean energy solutions, efficiency measures, and sustainable practices are actively developed and implemented. It's more than a concept. It's happening now. More than 62 initiatives have announced worldwide. More than 244 stakeholders are involved in these corridors globally. But here is the reality. Many corridors are still in the planning phase, and none are operational yet, unfortunately. So the big question is, how do we move from plans to real implementation? Okay, let's take a closer look at Canada's role in green shipping corridors. Canada is actively involved in 5 corridors, each with unique challenges and opportunities. First off, the first Pacific Northwest to Alaska, which is focused on cruise vessels sailing between Vancouver, Seattle, Victoria to Juneau in Alaska, and Montreal to Antwerp, and an important transatlantic route for East Canada, and other corridors that you can see them here. So as you may have noticed, among those corridors announced by Canada, two of them are in west coast of Canada in BC region. Ports such as Vancouver, Prince Rupert, or Victoria will be involved in these 2 corridors. Here you can see how important these ports are to Canada's economy. Just give you a number, more than 65% of Canada's marine import-export pass through the port of Vancouver and Prince Rupert. So yeah, let's dive deeper into what it takes to develop these corridors. Okay, in this slide, you can see nearly all potential technical solution for the energy transition in maritime industry. Each individual block here in this graph represent a unique opportunity for investors in this region, including generating low or zero emission electricity from renewable energy resources, using those electricity to produce low or zero emission fuel, and utilizing those fuels and low emission electricities on board vessels or at ports. But it's not simple. It's very complicated puzzle. So to have a successful green shipping corridor, we need engagement from different stakeholders: ports, bunker suppliers, vessel operators, shipping companies, investors, policymakers, or even local community. Yeah. And I would like to mention that challenge is not the lack of resources. It's about scaling up infrastructure and ensuring long-term supply stability. Yeah, each pathway requires massive investment, regulatory adjustment, and industry collaboration. Yeah, and okay, that's what we are doing right now at UWIC, University of Victoria. Our research project goal at UWIC is to develop a real world solution for implementing a green shipping corridor in the region by first assessing the low or zero emission energy resources in BC. Second, understanding what's demand and market potential. And finally, developing an implementation roadmap covering all technical, financial, environmental, and regulatory aspects. Yeah, it's our plan to balance the benefits of green shipping corridor across economic, environmental, social, and and other factor. Yeah, it was a very short and a brief introduction to the concept of green shipping corridors and maritime energy transition in maritime industry in the region. Thank you.
Thank you, Sayed. I mean, yeah, you're right. It's a short introduction. I mean, it's a huge problem. It's a big issue, and it's commendable the work that you and UVic are doing to try and make some sense of it. Um, I noticed on one of the graphs there, and we'll come back to some questions at the end here, but one of the graphs talked about renewable energy required for electrolysis to potentially produce methanol and ammonia. So that gives me a good segue into our next speaker, Riley Richardson, who is a project manager at Primed, which, Riley, Pacific Regional Institute of Marine Energy Discovery. How did I do?
Yeah, perfect.
Got it. Perfect. So with Primed, which is a UVic research group, or you can explain it, Riley, better. He oversees a diverse portfolio of marine renewable energy projects and manages engagement with external stakeholders. So Riley, tell us how this region is going to answer the energy problem.
Thank you so much, Jason. So yeah, I'll just get started with kind of a brief introduction of what marine renewable energy actually is. So it comes from any resource within the marine environment, and that can be indirectly from solar radiation, so talking about wind and waves, or directly from forces such as gravitational forces, as well as differences in physical characteristics in the ocean, so temperature and salinity. In BC, the resources we have available are wind, wave, and tidal. And you can see the global theoretical resource is massive. So it actually dwarfs the total electricity consumption globally. But despite the abundance of the resource, specifically for wave and tidal, there's been very little installed capacity in the water. And for reference, an installed capacity of about 1 megawatt could provide the annual needs of about 800 average homes in BC. When we start looking at BC, we're also blessed with quite a large resource given our extensive coastline. The theoretical resource represents the total energy available in the environment, and what we really want to downscale to is the practical resource, which would be much smaller. But even if we were only able to capture about 1% of this resource, it would be equal to about 6% of the total electricity in demand in BC. So the resource is there, and it's a really great opportunity to capitalize on for a few different reasons. One of the greatest benefits is its predictability, and this is key when you're looking to integrate renewables into any energy system, whether at the utility scale or the microgrid. Knowing when that energy is going to be available and being able to plan for that is crucial. And tidal is kind of king in this regard. So you can predict days, months, and years into the future how much energy could be produced at a given site. Wind and wave also have this really great alignment in that the peak in resource availability also coincides with when demand is highest in BC in the winter months. Given that water is 800 times denser than air, it has really high power density, so less area is required for wave and tidal to produce the same amount of energy as an onshore renewable such as solar. And then perhaps the biggest is with about 70% of BC's population living in coastal areas, and for globally, it's the same as well, and a concentration of remote communities that are currently reliantly on diesel. The resource has great spatial proximity to demand centers, and then as Saeed was kind of mentioning, especially for areas in the Salish Sea where you have very predictable routes of ferries or transportation, recreational marine traffic that could be electrified or use alternative fuels. Having that resource close by and other industrial activities really provides a great market for marine renewable energy. However, it's not without its challenges. Primarily costs, although offshore wind has made enormous strides and is one of the cheapest available energy resources on Earth. Tidal's lagging about 10 years behind that, and wave even further. So the cost of actual device design, getting them in the water is quite expensive still at this stage, as well as transmission. And so this is not only the cost of bringing electrons from the offshore back onto shore through submarine cables, but if we're looking at building out and really contributing to a greater impact to the provincial grid, most of our energy generation and therefore the high voltage transmission lines are in the interior region from those large hydroelectric dams that we're fortunate enough to have. But on Vancouver Island, for instance, going out to Euclid or Tofino, there's not really that capacity that if we were to build out large-scale wave energy, for instance, or offshore wind off the north end of Vancouver Island to transmit that power back to our larger demand centers. Establishing supply chains to bring costs down remains an issue, and identifying service providers. So areas such as Europe, who are kind of leading the way in terms of tidal development, are really benefiting from services and vessels that were first developed for offshore oil and gas, and then have now been applied to offshore wind, and then are having derivative benefits with tidal. So those specialized vessels and equipment, we don't have as much of those available on the West Coast. The high energy density is great, but that also means high loads acting on devices, which can increase the risk of failure. You need to deal with issues such as biofouling, which can really impact the efficiency of devices and their ability to produce energy over time. Dealing with corrosion, and then weather windows is a really big consideration. So this is not only for primed when we're out doing field work to characterize the marine resources, but looking at weather windows to install devices, then to go out and maintain them manually. In terms of regulation, the regulations both at the provincial and federal level aren't necessarily fit for purpose. So that's an area where Primed is trying to make some positive strides forward. And then really trying to balance the development of marine renewables with other uses of the space, especially in BC. There's very intrinsic cultural, ecological, recreational values, and then of course the plethora of marine industries and economy that already exists. So in developing marine renewables, we need to make sure that we're doing so in a way that coexists and has co-benefits with these other uses. Finally, although there's been a lot of research to date through demonstrations and modeling to show that the environmental impact of a single or a few marine energy devices is minimal, when we're looking at large-scale arrays, so tens of devices, the cumulative impacts are not necessarily clear. So for an example, if you have a tidal array of multiple devices, how could that impact whales' ability to navigate through that area? And finally, I'll touch a bit about what Primed is. So we're a marine renewable energy research and development center based at the University of Victoria. We're a small team of about 10 researchers, and we really work with communities, the private sector, and government in an effort to sustainably harness the ocean energy available in BC and decarbonize energy systems. So we do have a focus on community scale where communities are reliant on diesel and costs are much higher. So kind of splitting between the remote or microgrid market and then looking forward at ways in which marine energy could play a role at the utility scale. So we do that by deploying devices such as this acoustic Doppler current profiler or wave measurement buoys. And then Ignacio on the team does a really great job of creating resource models that we can then take with other ecological considerations, shipping traffic, recreational uses to try and figure out where some of the practical resources are. So here looking at some of the tidal resources available around the greater Victoria area and the Gulf Islands. A big piece with the integration of renewables is how do you actually balance their variability and intermittency in being able to meet demand, and pairing that with incumbent generation systems such as diesel in the case of a community energy system, as well as battery storage and onshore renewables such as solar and wind, and really looking to minimize diesel use in that context and also minimize cost. Looking at regulatory reform and policy development, so ensuring that there's policies that incentivize companies to build out projects in BC, simulating and modeling different devices and mooring systems to try and optimize the effectiveness, while also ensuring that the technologies are able to withstand the forces acting on them. And then we play a role in supporting small-scale demonstration and operation of projects. most prominently with the development of a tidal energy demonstration center at Blind Channel that will really help us to work through a multitude of these challenges in sort of a living lab and enable the testing of other technologies. And then social research to really understand perceptions towards marine energy and how do we integrate it sustainably within the marine space. Thank you so much, Jason.
Thanks, Riley. And I can't say how much it's very beneficial for this region to have a group like Primed and what Primed has evolved into. We often have conversations with companies from outside of BC and outside of Canada interested in being here because of the opportunities to work with Primed and also some of the other industries in this sector. So it's a huge asset that we have in this region. And thank you for the work you do, Riley. So we've talked a little bit about demand on the marine decarbonisation side. Riley's given a little bit about how we might be able to meet that. A lot of those are longer term ideas and concepts. We're very lucky to claim Harbour Air as a blue economy company today, but we're very lucky to have Erica Holtz and later Suzanne Brensky to talk about Harbour Air because they're actually doing this at the moment. They're moving forward on their decarbonisation plan quite aggressively and actively, and it's a great story. So I'm going to pass it over to Erica first, who in her day job, I guess, is the Manager of Quality Assurance with Harbour Air, but more importantly, she is the leader of the E-Plane project. So we're going to hear from Erica about their pathway and their story on the E-Plane. Thanks, Erica.
Fantastic. Thank you. I'm excited to be here to share a little bit about what we're doing. I'm going to be pretty quick going through this because I'm more interested in what the questions are that other people want to know. This is my favorite topic. I could talk about it for probably 3 days. But what are you guys interested in hearing? So I'll just give you a brief overview of what we're doing. So this is the aircraft that we built. It's the e-Beaver. So it took a piston beaver, converted it to fully electric power. So we have a Magni 500 kilowatt engine on the front. We replaced the fuel system with lithium-ion based batteries. And kept everything else pretty much the same. The propeller is new. Some of the interactions for the pilot are new. And then we've been spending the past few years test flying it in our local region to test out performance such as takeoff, climb, cruise, noise, also exploring things that are of regulatory interest like cooling on the engine and the batteries, loss of power control behavior, and then what's more interest to our company and to our end user, the potential passengers, is the operational behavior. I know because of where you guys are in Victoria and us in Vancouver as well. So while I could talk a lot about different performance characteristics, one of the things that I think is of most interest to people is noise. So while it's an electric engine and the electric motor is pretty quiet, doesn't make much noise, you still have a propeller, and the propeller still makes noise. But we've made some improvements in this area that, on average, it gives us a significant reduction, about 20 decibels in each phase of flight. And I know that that's of significant importance to the urban areas that we fly in and out of every day. We did some operational point-to-point flights. So we flew from Richmond to Salt Spring and then Salt Spring down to Victoria and back so we could bring the aircraft to you guys so you got to see it. But this was also to test how it behaved in the operational environment. And this is where I think we discovered many, many challenges that we are going to face. One of the biggest ones is probably tied a bit to what Riley talked about, is it's about energy production and energy storage. Our locations were not really prepared for us to bring the aircraft to them. We actually had to wire in at least 220 volt plugs in each of the locations that we went to because the power simply wasn't available. And on that charging capability with our 7 kilowatt charger, it took us 16 hours each time that we landed in order to charge. So that's one of our biggest challenges or opportunities, really, to harness the energy, perhaps out of the ocean, perhaps out of the sun, wherever the energy source comes from. We need to ramp up production of energy and storage of that energy. And whether that means companies like us have microgrids so that we can help store the energy for our particular needs, or whether it's larger storage by a utility company, That's one of the problems. It's a little upstream from my problems. I know it's a problem for where we're going to need it to be, but I'm focused more on the aircraft itself, getting it to certification and the regulatory challenges associated with that. Since electric engines have never been certified before, it's very difficult for the regulator to figure out what is the path to certification. If we don't know what the bar is set, how do we jump over it? But overall, the aircraft behaved incredibly well on our routes. We've, of course, had many lessons learned on things like how sensitive electronics are to water. So many things for us to figure out on our side. Next up for us, we're doing some more flight testing in the near term, some position error correction, make sure we have a good baseline for the aircraft, some stall demonstration in comparison to baseline. We need to explore behaviors at higher altitude. It's something that's a known potential issue with the electric motor, and the high voltage that we're running through the battery system is partial discharge starts to happen as you close in on 10,000 foot altitude. We've also found that while we're very much interested, our sole concern is, of course, getting the Harbour Air fleet to electrified. There are a lot of people who have come to us and want to be able to use the technology in their environments as well. But the majority of them want an aircraft on wheels. So one of the campaigns we're going to do in the near term is to put this aircraft on wheels and see what our performance characteristics are like on wheels. We also need to expand the envelope. So far, we've done some very, I'll call it safe flying in terms of staying way within the operational envelope of the aircraft. For example, there is no real wind limitation on the airframe itself, but we've been only allowing it to fly in 15-knot winds. This is just to make sure that Transport Canada was a little concerned at the very beginning. It's a brand new technology. How's it going to behave? So we've been slowly expanding that envelope as we prove each time that it's safe and works within the envelope that we have. We still need to do some design work, like you see on the bottom of the aircraft there at the back. There's a ventral fin. Operationally, we don't like it. It has a tendency to run into docks and equipment on docks, but it may be needed for lateral stability of the aircraft. So we're exploring that. Finlets, what other else things we might need to do to the aircraft, and some propeller information that we desire for certification. So why are we doing this? I think this is one of the key points. You'll hear a lot about how, electrification isn't there. It's not that useful. Aircraft can't do it. Well, we are probably in many respects the gateway airline to bring electrification to commercial markets. The reality is we have very low energy requirements. We don't fly incredibly high. We usually are somewhere around 20 to 30 minutes flights for the most parts on the majority of our routes. Some are a little bit longer, and we don't fly much higher usually than 1,000 foot. That means that the energy required to perform our mission is quite low compared to most airlines. So this results in us being able to use the technology that's available right now. With the aircraft that we have flying on what I'll call yesterday's technology, we're able to do a 50-minute mission. That means 50 minutes of available flight time, including your reserve that you need to have on the aircraft. So we've flown for 30 minutes with this technology, and we've flown up to heights of about 2,500 foot. And it's performed exactly as we expected, and the energy density of batteries is improving. Today's technology, which we're implementing into our test aircraft now and will use for certification, indicates that we would be able to carry, it's going to range a lot depending on regulations and certification, but probably 3 to 5 passengers for 30 to 45 minutes, depending on some of the factors around that certification. One of the great things too about this, when you talk about urban air mobility or advanced air mobility, is we don't need to build any of the infrastructure. We already have it. All we're doing is changing the propulsion on our existing aircraft that are in our existing bases. We also have a very unique set of skills. Not only are we the operator and have incredible operational expertise and a pool of experienced pilots, but we also have our aerospace division, which has an AMO that's been in operation for over 40 years. That's a maintenance organization. And so they know how to maintain, modify, and manufacture parts for these aircraft. We also recently obtained our design approval organization status with Transport Canada, and that allows us to sign off on the certification of modifications and repairs to these aircraft. It's not a skill set that is usually combined. Usually you're either an airline or an AMO, but with both of these, we are uniquely positioned to be able to bring this technology forward. So for us, commercialization steps, yes, a big focus is, of course, getting Harbour Air operating on these aircraft, but there's also, as I said, been a lot of interest worldwide on this product, which is why last year we signed a letter of intent with magniX for 50 aircraft to secure our supply chain. It's intended, as I said, for both our airline and for third party. We'll continue to work with the battery suppliers to find the optimum solution for our aircraft to optimize the performance of the aircraft. Again, because of our short missions, the requirement isn't that high. I don't need a full fuel tank in order to fly the missions we have. So finding that battery size pack that works for our exact missions and optimizes the amount of passengers I can fit in, that's our goal. Our initial STC target is for late 2026. This will likely not be what I would call our commercial offering. This will be the first kick at the can with the first set of batteries that will allow us to fly. We'll probably use this as a tour machine for Harbour Air. While we look at the next battery pack that would be the commercial operation, commercially viable aircraft, and that would come into play probably in 2027 for any of our third-party customers. And right now we are signing letters of intent with potential customers so they can come participate in the project and try out things to see how it would work in their operational environment. So Jason, that's it for me. I can pass it over to Suzanne. I'll be playing the slides for her.
Perfect. Thank you, Erica. And yeah, it's great to hear someone actually going through this transition, and it's fantastic that's on the doorstep of Victoria, and it's great to see Harbour Air doing that. So I'm going to pass it off to Suzanne. Suzanne is the Harbour Air's head of digital and customer experience. And I guess, yeah, Suzanne, you're going to talk about how your customers and, you know, how the process is going to happen with this decarbonisation and the support behind it. So looking forward to hearing that. Thanks, Suzanne.
Wonderful. Thank you. Thank you, Jason. My name is Suzanne. I'm the head of digital and customer experience at Harbour Air. Following up on Erica's very cool presentation, I'm going to touch on some additional elements of our sustainability strategy. In my role, I'm responsible for all things customer, including architecting the customer journey from booking search to flying to finally driving away from the terminal, hopefully in a low emissions vehicle. A significant part of our customer journey and one of the elements that makes Harbour Air so special are the sustainable elements of our offering. Harbour Air has a long history of sustainability and has long appreciated the importance of doing its part, and we understand that a significant element of our success is tied to the West Coast experience that we offer. Harbour Air has long been a pioneer in this space with initiatives such as the e-Beaver, as well as initially its offsetting and now it's insetting elements. And for a bit of history, Harbour Air began to offset emissions in 2007 on behalf of customers and was proudly carbon neutral. Back in 2007, offsetting was very much in its infancy, and this was industry leading. In 2024, we switched to an insetting model in order to double down on investment within the e-Beaver program, because we view that as our best investment in long-term GHG emission reduction. In addition, Harbour Air has other sustainable elements in its customer experience, such as the operation of electric shuttles and sustainable merchandise available for purchase. In addition, with our Share the Fare program, we support the Clayoquot Biosphere Trust, a registered charity and a UNESCO site. So I'm very happy to be here and happy to answer more questions on our sustainability journey and other elements. So thank you very much for having Erica and I.
Thanks, Suzanne. So good timing. I think the questions are open. I'm going to ask everyone to put their cameras back on and their microphones. We've got about 15 minutes for some discussion. We've got some questions I've got, but I'm really hoping we might see some questions from the audience as well. I'm going to start. Thank you all for participating. It was really good to talk about, you know, the maritime industry or the shipping industry and where it could go, and then to talk about with Harbour Air, you know, the fact that you're on this pathway already. So I'm going to start with you, Suzanne, and I guess the question from me is, this is going to take a lot of investment, and you talked about offsets, and I know with, you know, booking flights on different places, you can choose to offset your costs, etc. Without sharing too much financial information, are you seeing people wanting to participate in this, and is it going to be enough to see that transition occur?
Yes, so that's a great question. To your point, it absolutely does take investment, especially when you're at the pointy front end. It takes investment and, frankly, risk. We have had some really fantastic support from our customers, for which we're extremely grateful. We're also in a really great province for this, given there's all kinds of evidence of the propensity for customers in BC and to demand and to want sustainable options. We've actually received quite a bit of really positive feedback on our eBeaver program. But to your point, it does require quite a bit of investment. We've moved from an offsetting model to an insetting model recently. And insetting, we define as actions or investments within our own operations, production, or value chain for the long-term sustainable mitigation and avoidance of emissions. Essentially, what we do is we have a sustainability fee on all of our flights for the Vancouver to Victoria route, which you guys are probably well versed in. It is $1.18. And essentially, what we're doing with our this fee on all of our tickets is we are moving that to support, or we use that to support the ePlane program. This replaced our old offsetting fee. So for those emissions, so what we've done is for emissions associated with our aviation fuels, we've moved to the insetting model to accelerate the ePlane program, because we feel that that is the best investment vehicle to combat long-term emissions. We still continue to offset other emissions. So for Scope 1 and Scope 2 other fuels, we still offset those, but we have moved to an insetting model for emissions associated with aviation fuels. So when people ask, how do we help the ePlane program? What we say for consumers is to keep flying, because every ticket that is purchased goes to help fund the eBeaver program.
All right, I guess I'm going to have to, pay that extra $1.18 every time now. So good plug there.
Thank you, Jason.
I'm gonna actually go. Thank you, Suzanne. I'm going to talk to Erica now quickly, and we had a couple of pre-planned questions, and Erica, you kind of answered this question in your presentation, so I'm going to have to. You shouldn't have done that, because now you don't know what I'm going to ask you. But one of the things you did bring up was, the noise, and it's something that's obviously is of interest to lots of residents and etc. But I also want to know if are you seeing any other benefits with this transition to an electric plane? Is there, for example, I mean, obviously there's, you don't need the fuel, so you don't have the GHG, but are there any other things you're seeing, like in terms of your performance, or is there anything else that's going to help from a commercial perspective with Harbour Air?
Yeah, actually, I didn't talk about all the different performance things, but we actually really had a significant performance improvement in this aircraft. So, the piston engine is a huge radial. It blocks a lot of the propeller because it uses that airflow to cool the engine. We no longer need that level of cooling. The engines are a lot more efficient. They don't produce as much heat. And so the cooling requirements were significantly reduced. So we got to put a pointy nose on the aircraft, which reduced the parasitic drag, but we also significantly reduced the cooling drag. So there's a scoop on the bottom that intakes airflow over a radiator that cools the oil system for the engine. It's a lot less hot than the original aircraft. So the cooling drag and the parasitic drag accounted for, what did we have? I think it was a 36% reduction in the power required for level flight. So what that translates into is honestly, when we first flew this thing in December of 2019, our estimation was an 8-minute flight, because 65% of the battery pack was going to have to be used for reserve, because we didn't know we would get such an improvement in the performance of the aircraft, right? So because the original aircraft required 62% of power for level flight, we're down to 40%. It's a significant improvement. The aircraft, it wants to fly faster. So we get to restrict the power to fly it slower. As the pilots have said, it's the sportiest Beaver they have ever flown.
So you get more pilots wanting to come and work there. So there's an extra benefit as well. It's easier to attract pilots. Perfect.
Well,
all
and
these
also
benefits.
AMEs. The people we've hired over the past couple of years have explicitly stated one of the reasons they've come to work for Harbour Air is because of our sustainability initiatives, in particular the eBeaver, because they want to be able to work on that technology. It's been a really good attraction for people wanting to work in the aviation field. In fact, the aviation field has really stagnated over the past 50 years. There hasn't been any new or novel technology in like 60 years since the turbine. Like honestly, like no big, incredibly fun things, but this is so novel and so transformative for the aviation industry. I think it's going to make aviation sexy again.
Well, I mean, yes, and I was going to chat to Riley next, but I'm actually going to flick this over to Sayed, because is there a lot to learn here, say, potentially when we're talking about maritime shipping and obviously the green shipping corridors, but is there some parallels to learn here from what Harbour Air and this transition's going through to basically maritime decarbonisation as well, especially with other benefits, but to use Erica's term, make shipping sexy? Sayed, you there? Can you hear us? Oh, you're on mute, Sayed.
Sorry, I didn't hear you. Can you repeat, please?
I'm just wondering, when we're talking about with shipping and the transition that Harbour Air are doing with other benefits, with the technology advancements with electric planes.
Yeah.
Obviously, we're not going to electric shipping, but we're going to look at different types of fuel types. Is there some parallels to look at, that there's some other benefits with respect to maritime decarbonisation rather than just the GHG emission reductions? Do you see that?
Yeah, actually, because both industry are international, and the marine transportation is international, the aviation is international, and in some point they have same strategy regarding those alternative fuels. So, and but in maritime transportation, what I can say, there is no a single solution. We will have different type of fuels in different ports based on the region capacities, and based on vessel type, based on the route. So we will have different solution, different alternative fuels in different region, and yeah, it depends on many things, such as location, such as vessel type, and yeah.
Okay. Riley, back to you. A lot of it's been done about ocean energy. There are obviously lots of roadblocks. You talked about some of the barriers. Do you see the opportunity here with even some of the stuff that Harbour Air is doing in remote areas about ocean energy really actually solving some of these problems? And what are kind of the major roadblocks right now to, if they can, what's the major roadblocks to getting them there?
Yeah, definitely. I mean, right now with having higher costs per unit energy, an application that really makes a ton of sense is remote communities that are reliant on diesel, many of which are coastal First Nations right now. So we work on quite a few projects, for instance, with Wachamuchelet First Nation on the feasibility of a wave energy project, where even at higher costs, Wave and Tidal are competitive with the incumbent, whereas it might not be so on the grid scale, where the price we pay is about 11 cents per kilowatt hour. But globally, looking at some of the challenges, I think for Wave, it's moving out of that prototype stage, with which quite a few companies are. And there's some really great test centers around the world, PacWave in the US, and then the European Marine Energy Center up in Scotland, that will get the technology to what's called technology readiness level 8, where you have kind of the full scale device operating and being certified. So I think that remains a barrier for wave energy, is really iterating on design and finding effective ways to harness the technology, the resource. And then for tidal, Europe's really made huge advancements in the past 5 to 10 years, and we're starting to see commercial scale projects that have really strong public support. So building out to tens of megawatts at a price of about 70 cents per kilowatt hour. So still much higher than what we're paying in BC, but we're starting to see those costs come down. So there's a bit of a disparity in the development of those two technologies. And then in BC, it's having, you know, regulatory frameworks that are fit for purpose so we can get devices into the water and demonstrate in those remote community applications the benefits of these technologies and work through, you know, specific challenges. If you're deploying a tidal device at a test center, which can essentially absorb as much power as that device can generate, that's much easier than a remote community where you can't curtail that power necessarily. You might not be able to store it. So that provides a bit more of a unique challenge. And I think longer term, looking at the grid scale, in the 2010s, BC Hydro discounted solar and wind. And now that's the exact technologies that have really become cost effective. And the Power Call has 9 onshore wind projects and 1 solar project. So building out policies to support marine energy and a regulatory framework so we're prepared when those technologies are cost effective. For instance, they're scrapping all environmental assessments for onshore wind in order to be able to produce these projects quickly. So I think we can really be prepared to harness what is a really large resource in BC into the future.
Okay, thank you. We've got a couple of questions from the audience. Erica, I think you might have opened a can of worms here when you said there hasn't been a lot of innovation going on in the airline industry. There's a question here about, are there any other new emerging ideas that are on the table that you can potentially share in terms of where this is going? I mean, either in decarbonization or anything, we can just open it up.
Sure. Really, I meant like major disruptive innovation, right? Like the turbine engine. After that, it's all pretty incremental, but there's some really cool things that are happening right now. One of them is like Bombardier and their EcoJet. They're one example, but there are a lot of examples of what they're calling this blended wing technology. So you're making use of the fuselage body for lift, right? It actually looks like it's going to improve customer comfort potentially, unless they cram very, very many people in there. But it's an interesting idea on the technology. You can look those ones up. It's called the blended wing technology. There's a lot of work being done in hydrogen right now in Canada. One of the coolest projects I think out there is the H2 Can Fly being done as a consortium with the NRC. So they're going to take a BAE 146 aircraft and outfit it with hydrogen. So there are a lot of questions around hydrogen. Many people think it can't work. It can work. So they're putting together a technology demonstrator that's going to answer that question for us in Canada. And it also gives us an opportunity then for anybody who's working in that sector, in working with hydrogen, is once they've got that test bed flown, you want to test out your equipment. You want to see how it behaves. You can take it to the NRC and test it out on their flying test bed. So there's some really cool innovation. A lot of it happening here in Canada, which is really exciting. So just quick Google, you'll find 100 of them.
And it sounds a bit, Erica, like a lot of these are related around the decarbonisation opportunities as well, right? I mean, you know, better, more lift. I'm going to really get myself in trouble here, but I'm assuming that's going to improve efficiency and reduce fuel and all of that stuff. So yeah, it's all with this decarbonisation thing in mind, and getting more people in the plane, of course.
There's significant opportunity. Absolutely.
Oh, that's good. There's a question here. Obviously, BC Hydro is a big piece to play on this, and I know they're on a panel later on today. I think on one of the energy panels. But you would think that there's a lot of energy potential and a lot of electricity production that's going to happen. And maybe Riley, you can take this one, which is just about is BC Hydro being involved and connected and much about supporting this sort of initiative, looking at different types of renewable energies, different usages of it with sort of harbour air and other potential demand requirements? How much is BC Hydro involved with yourself?
Yeah, so we work with their non-integrated areas group on some of the remote community projects, and then as well, one of our big focuses, and it's a research paper we're trying to get into BC Hydro's hand, is looking at the wave resource and finding those sites that could support commercial projects into the future, and trying to really take the global state of knowledge, especially for tidal, which I think could be integrated into future power calls, to have BC Hydro have that be an eligible technology. So right now, an eligible technology has to be demonstrated for over 3 years, 3 different projects in what's considered good utility practice. So BC Hydro has a mandate to provide reliable power and to reduce costs as much as possible for the ratepayer. So we have some connections with BC Hydro, and I think Prime's role is really to take the understanding and inform BC Hydro or inform communities of what the technologies could provide, as well as some of the challenges, and then work proactively to try and get uptake.
Perfect. We're out of time. I got a whole heap of questions I was planning to ask you, but it's just so much information back and forth. Thank you so much. I don't even know if we've got time for summaries. I think we're going to get kicked off here, and there's more stuff to talk about for later today. But I really want to thank you all for joining. It's been a great introduction to me, to a couple of you as well, and thank you for providing your time. And it really, for me, it's really encouraging that we have these organizations and these entities in this region that, as I said at the top of this, we can really be a global leader in decarbonization in this aspect. So thank you all. And I'm going to hand it over to Ben, I think, who's going to tell a little bit the viewers about some more panels coming up.
Thank you so much, Jason.
So I just want to say thanks to the speakers. Thank you to the attendees. Thank you to Capital Daily for sponsoring this important conversation today. Thank you to our presenting sponsor, RBC, and our catalyst sponsor, Van City, for supporting Rising Economy 2025. This conference is also presented in partnership with Pacifican. We also want to thank the attendees and encourage you to head back to the Whova platform to continue the conversation. There, you can check out the event agenda and the upcoming sessions today, and you can also head to the community section to check out the exhibitor booths, join virtual meetups, and engage in discussions. Coming up next is Demystifying AI for Business, followed by crisis-proofing your business in the age of wildfires, floods, and earthquakes. Thank you for joining us today.